Welcome back to part 2 of the Raspberry Pi GPIO tutorial series. In the last video, you learned how to make an LED blink. In case you haven't seen that one and would like to, I'll link it in the description below. But in this tutorial, we're going to be learning how to use a button with the Raspberry Pi GPIO pins. For materials, we're going to be needing a Raspberry Pi. Otherwise, it wouldn't be a Raspberry Pi tutorial. These are two male-female jumpers, a little piece of jump wire, let's see, and then also a breadboard, and the star of the show, a button. I salvaged this one out of a, oh, come on, focus. Oh, it's not focusing, but I salvaged that one out of an old VCR. In the second part of this video, we're going to be integrating video 1 with video 2, and if you'd like to follow along there, we're going to be needing an LED, a 100 ohm resistor, or in the ballpark of 100 ohms. That's going to be brown, black, brown for the color code, and then one more male-female jump wire. Some quick recap from video 1. GPIO stands for General Purpose Input-Output, and it allows our Raspberry Pi, this mini computer, to communicate to the outside world using electricity. I'm also going to recap quick how a breadboard works, much less in depth than in the first video, but if you look at this picture here, you can see that columns are connected and rows are connected. Basically, this allows us to make circuits without having to solder things up or leave lots of loose wires behind. You don't need a breadboard for this project, but it makes everything a whole lot easier. I'm going to be taking a lot of inspiration from the Raspberry Pi Foundation's project tutorial on this, so if you'd like to read more or have some visual instructions, scroll along with me there. Step 1, after you get all your materials, let's set up the circuit. Okay, reminder that these right here are the GPIO pins for the Raspberry Pi. There are 40 of them. This is the layout we have. We care about right now GPIO pin 2, which is right here, and then also the ground, which is a lot of options. So take one of your jumpers onto GPIO pin 2, and then I'm going to put it right into slot 10 in that row. That row doesn't really matter. Any row works as long as you keep the row consistent. And now I'm going to take my ground and put that into the third one down on the right, which is a ground, and then plug it into the negative column. Great. Take my jump and jump from the negative column to 2 down from red, so in row 12. All this needs for the circuit to be completed is for there to be a bridge from 10 to 12, and that's where the button comes in. I'm going to put the button on both 10 and 12 so that now when I push the button, it's going to complete the circuit and then run whatever code we'd like to run. Now that I've set up the circuit on my breadboard, I'm going to head over to my computer and start writing some Python code. Right here I'm SSH'd into my Raspberry Pi and I'm in the terminal. Open up the terminal on your Raspberry Pi however you know how. Okay, we're going to be using a text editor called Nano, so sudo nano, and then we're going to be creating a file called buttontutorial.py. Enter. Alright. What's going on here? It's just like Notepad or some other text editor. We're going to type from GPIO 0 import button. We're going to call our button variable is equal to button and then our GPIO pin that we plugged into, which was 2. Then let's type the function button.wait for press parentheses, and we're going to print the button was pressed. Okay, Control S to save, Control X to exit, And now let's run that button tutorial Python script. Whoop, still have caps on. Python. And then I can just type but tab and it should autofill. Otherwise just retype button tutorial.py and now run. Nothing's printing on my screen right now, and that's because I haven't pressed the button yet. Okay, I'm going to hold this very carefully. Press the button. Ooh, my button fell off. But the button was pressed. So we know we have everything working properly. Now let's make this a little more complicated. Let's get a bit more complicated now and add an LED. Okay, so like in last tutorial, we're going to use GPIO pin 17 for the LED. That's going to be the 6th one down on the left. We're going to put that in the positive column here. It doesn't matter where, but just have it in that positive column. Now, take a resistor from the positive column, and then I'm just going to put it into 40 here. Oh, come on. There we go. And then we're going to put the LED from 40 into the negative column so it gets back to the ground. Reminder, the LEDs have a negative and positive side. The negative side is the shorter lead, and there's also a notch. Here's the reference from the first video to help you out with that. So I want the positive lead in row 40 connecting to that resistor, and the negative to go into the negative column. And that is all you need to do to reset up the LED circuit. So we got the LED all wired up, and let's control that LED with our button press. I'm going to go back into that button tutorial.py. You can just use the up arrow to retype sudo nano. And we got our code here. Let's also import LED, if you remember from the last one. And then after button, we're going to make an LED thing. And that's in GPIO pin 17. And we're not going to do button.waitForPress, just plain like that. Before it, we're going to do a while true. Typically, this is bad coding practice because it's an infinite loop, but in this case, it works for our application. So, add a tab here after button wait for press. We're going to keep our print statement, but then we're also going to add led.toggle. So what this does is if the LED is off, it'll turn it on, and if the LED is on, it'll turn it off. This is probably going to glitch out and print a ton of stuff, so what we need to do here is add import time, and then underneath led.toggle, let's do time.sleep just for half a second. So we're not going to get an infinite number of presses. I think I need to make it a little darker in here for you to see, so I'm going to do that quick. But first, Control S to save, Control X to exit. I'm going to shut my shades and then I'll show you. Okay, it's a lot darker in here now. And let's run that button tutorial.py file. So Python, you can just type but and then tab, or type the whole thing in. Push enter. So now it's in that while loop, waiting for us to press the button to toggle the LED. I got my contraption right here. So now if I push the button, we see the button was pressed and the LED turns on. Let's press it again. Oh, yep, and we can just keep toggling it like that. And there's that half-second delay, so you can't just rapid fire press it. Control C to end that. Let's go one extra step. We're going to make a new Python file. Sudo nano button press.py. Let's do our imports again. From GPIO 0, import LED and button. We're going to make our button variable. So button is button in GPIO pin 2, and then LED. LED GPIO pin 17. So this is going to get into a little bit trickier Python, but it's straight off the tutorial. We have button dot when pressed equals LED.on. If you remember, LED.on is a method, so if you want to run that, you technically need parentheses after the on, but we're setting the button when pressed method to just do the LED.on action. And then we're going to do button.when released, that equals LED.off. And then one more thing. We don't want the script to just exit and end, so we need to do from signal import pause. And then at the end of the script, pause. It just basically keeps the script open. Control S to save, Control X to exit, and let's run this button press file. Python button press .py. Enter. Okay, so now it's just in a holding period. I've got my contraption here, and when I hold the button down, you'll hear the click. The LED's on, and when I release the button, the LED's off. Hold the button on, release the button, LED is off. Great, Control C to exit out of that. I'm going to open my shades quick. And that's all you really need to know on how to operate a button with our GPIO pins. Instead of controlling an LED, you can control lots of things. Like you could run a script to start a Google Assistant with your button press. You could make a smart doorbell for your house using this button and a Raspberry Pi. There are all sorts of projects like this available, and in a future video, I'm going to go through my top 5 Raspberry Pi GPIO project ideas for you. If you found this video helpful, feel free to subscribe to see more videos like this in the future. Give it a like if you liked it. Leave a comment if you have any questions. And happy coding.